negative 5 is, you typically say whatsoever is here, right? So you typically equate whatsoever is here to x plus 5 is equals to x. Remember our formula here, right? Is equals to x minus c. So what that means is if this is x, your c would be negative 5. Does that make sense at all? That's how you find the center. And it's very, very important for you to know how to find the center because we would be using the. Let's take a look at another question. If we have, try this and tell me, summation, let's see, let me write it down. Summation 3x plus 2 to the n is going from 0 to infinity. What will be c in this question? Does anyone know? Who can tell me what will be center? Try it and tell me what will be the center.
Yeah, C should be 2.
Did you agree? If you have an answer, let me know.
And minus 2.
Who has an answer? Yes. Negative 2 over 3. That's correct. Negative 2 over 3. How do you find it? There's several ways you could do it. To not get confused. Usually I get confused too. So what I do is I hypothetically assume the value of x when everything here is 0 would give me the answer. And that makes sense because if you look at everything here, if you say here x plus 5 is 0, x will be negative 5. That's why we find our center as negative 5 here. The value of x when you equate whatsoever it's inside here to 0. Because if you look at here, if you say x minus c is 0, your x will be c. So the value of x when everything inside this bracket is 0 is the center of the power series. The same way here it becomes 3x plus 2 is 0, so 3x becomes negative 2 and x becomes negative 2 over 2. That's how you find it. So if you have a power series, the value of x when everything here is 0 would give the center, right? And that is why when c is 0, our power series becomes this guy here. Okay, the next one is the radius of convergence. How? For rabbit. Does anyone know what this is? Anyone? I put the definition in this workbook, so you can look at it. The definition is there. On page 2. I says the radius of convergence of a power series is the distance from the center within which the series converges. So before that, let's talk about what convergence of a power series is. We said the power series at center c is equals to 0 is when n goes from 0 to infinity, a raised to power n, x raised to power n. That's what a power series is, right? So what this means is a1x a0x0 like this plus a1x1 plus a2x2. It keeps going, right? It doesn't end. Convergence means at the point where the power series stops, right? So that's what convergence means. It means because this one keeps going, so it gets to a point where it stops. So at that point where it stops, it's called the convergence. And then we define the radius of convergence. If you look at page 2, you will see that we define the radius of convergence as the distance from the center within which the series converge. So if we have, say, a power series, and this is the center, right? And the series is converging here. Let's say it's converged here. And it also converges here. So the distance from this center where it converges like this is called the radius. So that's what we call the radius of convergence. The distance from the center where it converges. Okay. We also define the interval of convergence. I. So if I use I and R, capital R, we should know the difference. So the interval, same on page 2. The interval of convergence is the set of all values of x for which the power series converges. So this one is set of all values. Because sometimes you could have more than one value, set of all values of x, for which the series converge. Let's take a moment to think about this because we're going to solve some questions. Questions before I continue. Let's take a moment to think about it. So we've defined the radius of convergence. We've defined the interval of convergence. The question now is, how do you find the radius of convergence? Those of you that have taken this class, do you remember how you find the radius of convergence? We use what is known as the ratio test. So to find the radius of convergence of a power series, we use what is known as the ratio test. We use the ratio test to find R. And ratio test simply say that limit n tend to infinity an plus 1 over an. This is what ratio test tells us. Limit. Ratio test is limit n tend to L. Ratio test L is equals to limit n tend to infinity a raised to power n plus 1 over raised to power n. I'll do some examples. Of course, this is math. We don't deal with definition in math. We do examples so we understand. Right. There are 3 case studies you need to know. Before we start doing examples, there are 3 case studies we need to know. Let me write it down. So, case 1. So, case 1 is when ratio test is equals to 0. That's case 1. Case 2 is when the ratio test is equals to infinity. And case 3 is when the ratio test is less than 1. So let's start with case 1. Does anyone know what case 1 means? When the ratio test is equals to 0. So for this is case 1, this is case 2, and this is case 3. Okay. Those are the 3 case studies you would ever encounter in this class. So does anyone know what case 1 means? When the ratio test is 0, it means that the series converge for all value of x. This one means that series converge for all value of x. So no matter the value of x, the series will always converge. The radius of convergence is infinity in this case, for this case, right? And the interval of convergence will be minus infinity to plus infinity. This is a very, very common case. I'll repeat what it means. When you do your ratio test, because to find the radius of convergence, we would always do the ratio test. When you do the ratio test, which is an plus 1 over an, and then you get the value of 0. If you get the value of 0, what it means that no matter the value of x, the series would always converge. That's one. Second, it means that you don't have a single value of radius of convergence. You have infinity value because the series converge no matter the value of x. And that means that your interval of convergence, which is the set of all value of x, at which the series converge, will be minus infinity to plus infinity. Because the radius of convergence is always infinity at this point. Question. Everyone is looking tired. We haven't even started solving. Okay, let's look at the second one. And I think I put it in your workbook also, so you don't forget. The case 2 is when your ratio test is infinity. Does anyone know what that means? When you do your ratio test and it's infinity, I put it on your workbook too. Does anyone know? What that means is that here, the series converge at x is equals to c. That's what it means. If your ratio test is infinity, series converge at x is equals to c. The second thing it means is that the series diverge at all other values of x. Except when x is equals to c, and c is the center. So when x is equals to c, the series converge. It diverges at all other value of x. That's what it means. Question. Yes?
What happens when x equals 2? Does it just equal 0?
Yes, it converges. Yes, that's when it converges. You're right. The radius of convergence is 0. You're right. So because of that, the radius of convergence is 0. That's a very good point. Yeah. And the interval of convergence is x is equals to c, because that's it. Yes. Question? Any other question? I mean, those are the three cases you need to remember for all. You don't also have to memorize them. You can put them in your workbook in exam. The third one is if it's less than 1. So when this is less than 1, typically the series will converge. Right? And then this condition, s minus c less than r holds true in this case. S minus c less than r holds true. Sorry, this is absolute value. Okay. Question. Okay, let's go back to our workbook now and do one example. Let's go to part A. Okay. Part A says question 1. Let me know if you're there. So, there are two things we have to determine. Let's do question 1 first. There are two things we have to determine using the ratio test. Number 1, we would calculate the radius of convergence. Number 2 is the interval of convergence. What am I? And here is the question. The question is summation x minus 3 to the n. N is from 0 to infinity. We're using the ratio test. Okay. We know what the ratio test says. Any question? Does anyone know how to start here? So you have the ratio test, and we're using the ratio test to do this. Anyone know how to start? Okay, so what that means is our ratio test L is given as limit n to the infinity a raised to power n plus 1 over a raised to power n. So what this means is that wherever you see n, you put a raised to power n, you put n plus 1 there first. That's what it means. Then wherever you see n again, you put n there and then you divide it. Let me show you. This is what I'm talking about. So here, we want to apply the ratio test. Our L becomes limit n to the infinity. We start with x minus 3. Instead of n, we put n plus 1. It becomes x minus 3 to the n plus 1. That's for a raised by n. A raised by n plus 1 means wherever we see n, we put n plus 1 there. That's what it means. Then divided by, again, x minus 3. Instead of n, again, a raised by n, we put n there. X minus 3 to the n. That's what it means. Then we simplify this. If we simplify this, this becomes limit n to the infinity. This the same thing by saying is x minus 3 to the n multiplied by x minus 3 raised to power 1 like this. Right? Yes. Divided by x minus 3 to the n. Okay. Let's use a colored marker here. So this guy cancels this guy. Do you agree? If I'm too fast, let me know. Just tell me to slow down. Okay, question. What I did is I used ratio test. And ratio test says replace n with n plus 1 at the top first, then divided by replace n with n. So there is only one n here. We replaced it with n plus 1, and then we replaced it with n, and then we divide. In the end, we're left with this becomes limit n to the infinity x minus 3, right? So there is no n here at all, right? So since there is no n here, so whenever you're left with a situation like this, it means that it's definitely not case 1, because case 1 n is equals to 0. We don't have any 0, right? Great. It's definitely also not case 2. Case 2L is infinity. And we don't have 0 on infinity. Assuming there is n here, assuming we have something like 1 over n here, And you know 1 over n, if n gets to infinity, this will be so small, it will be 0. Everything will be 0. But here we don't have that. So it's not case 1, it's not case 2. The closest is what? Case 3. So if you get to that case, and case 3 is less than 1, so what we'll say is we say x minus 3 less than 1. Right? So, now, from here, we can find the radius of convergence. Who can tell me what's the radius of convergence here? What's the radius of convergence? Remember the formula is, for this case 3, what is O2 is S minus C less than R. Right? So if we use that case S minus C less than R, so what that means is S minus C less than R. So if you compare it with this, our R would be what? 1. That's how you find the radius of convergence. So our R is 1 because case 3 says that it converges when it's less than 1 and when this condition S minus C less than R is 2. Right. Now, to find the interval of convergence, here is what you need to do. So what you need to do is, this is an absolute value. Right. And there's a way you can remove the absolute value. Does anyone know how you can remove the absolute value? This is the same thing as saying, if it's the same thing as saying, this whatsoever here, it could be minus 1 less than x minus 3 less than 1. You could do it. Whatsoever is here could be like this also, in negative, because it's an absolute value. So what that means is, if 3 goes here, it becomes minus 1 plus 3, that is 2, less than, if 3 goes here, it becomes 3 plus 1 less than 4. So what that means is the interval of convergence is between 2 and 4. So the interval of convergence is 2, 4. And the radius of convergence is 1. So at this point, the series converge. That's how you do it. It's the same process for all. So I'll let you try question 2. We'll do question 1 to 6, but I'll let you try question 2 yourself.
Sir, I have a question.
Yeah.
Sir, this n plus 1 in subscript or superscript?
It's sub.
So
what this means is you replace n with n plus 1 in the function. That's what it means.
Okay.
A is the function.
Okay.
You replace n with n plus 1.
So an is equal to x minus 3, right?
Yeah, a is x minus 3. You're right. An is x minus 3.
Okay.
Of n to the infinity. So an is, you replace n with n plus 1, right? So this guy becomes n plus 1. This guy becomes divided by 2n plus 1. Am I right? And this guy becomes xn plus 1. Remember, it's division. An becomes this same one, but we flip it. So if you flip it, it becomes 2n divided by nxn. Do you agree with me? Okay. So let me get a colored marker so it becomes. From here, this becomes n plus 1. This is xn multiplied by x, right? Divided by this becomes 2n multiplied by 2. Then we have multiplied by 2n over nxn. Okay, this is where it gets tricky. Let's cancel out. Remember, it's limit n to the infinity. So xn cancels out xn, right? 2n cancels out 2n. So we are left with I'm not going to clean this because we would always use this one. I'll keep this. So we are left with limit n to the infinity n plus 1 over n, right? Multiplied by x over 2. Did everyone get it up to this point? Okay. Now, what is n plus 1? If you're going to infinity, what would n plus 1 over n limit n tend to infinity be? It's 1. Because no matter, assuming you put 1,000 here, because infinity could be large value, it could be a million, right? If you put 1,000 here, 1,001 divided by 1,000 would be 1. The higher the value goes, the more it approaches 1. So everything here is 1. Because n is approaching plus infinity, so it's going to be very large. So it's 1. So that becomes, if you evaluate the limit, that becomes x over 2. Right? And then it's not case 1 because we didn't get infinity. Okay, it's not case 1 because we didn't get any 0 value, right? It's not case 2, we didn't get infinity. So we say it's case 3 less than 1. Case 3, we always say less than 1, right? So that becomes x less than 2. And this series itself has a center of 0. So that can be x minus 0 less than 2. This is absolute value, don't forget. This is absolute value. So we relate it to s minus c less than r, which is the one of case 3, right? So that means our radius is 2. That's our radius is 2, like we did before. So our interval becomes, remember, if you want to remove this absolute value, whatsoever is here becomes minus 2 less than x minus 0 less than 2, which is the same thing as minus 2 less than x less than 2. So our interval becomes minus 2 to 2. Like we did before. Most of you got it right. Here is where, when you get to this limit place, which you will get in so many questions, you have to start thinking, will it be 0? So the way I do it is, I assume a value of, say, 100,000 to n. Right? And I put it here and I punch it in my calculator. You see you will get 1. So if you ever face a question like this, just assume any large value and see what you will get. Sometimes you can get 0. For example, if I end up with something like, say, 1 over n squared, I know this is definitely 0. Right? Because if you put 100,000 here and square it and 1 divided by that is 0. So that's how we know. Question. So try question 3. We're going to do question 3 and question 4. Question 5 and 6 is your homework 1. Is in your homework 1. So you don't have to worry about that. You do that. Summation infinity n to the 0 x raised to the power 2n over n factorial. To 0 x2n over n factorial. So we're using the ratio test, which is our L is limit n to the infinity an plus 1 over an. Okay. So that became an plus 1. This one becomes limit n to the infinity x 2n plus 1. Because n becomes n plus 1, right? Divided by n plus 1 factorial like this. That's for this guy. Then for this guy, we flip it over because we divide it. So this becomes n factorial over x2n like this. Okay. Here is where it gets interesting. These two has to multiply both. Do you agree with me? So this becomes limit n to the infinity. This marker, I paid so much for it and it's happy. x2n plus 2. So this guy here becomes n plus 1 multiplied by n factorial. That's what n plus 1 factorial is. Then multiply by n factorial over x2n. This one would cancel out one of these two n. This n factorial will cancel out this. And we are left with, let me know if you get the same answer or something different. We are left with limit n to the infinity x squared, let's put x squared apart, multiply by, and then we have 1 over n plus 1. Is that what you got? Okay, so what is 1 over n plus 1? Limit n to infinity. If n gets to infinity, what happens to this? 0. Because just imagine you put 2 million here. It's going to be 0. So everything here is 0. So 0 multiplied by s squared is 0. And that is case 1. And case 1, we say that if our limit is 0, your radius is infinity, right? And then interval is minus infinity to plus infinity. What this means is no matter the value of s, the series converges. That's what it means, right? So this is case 1. As long as you remember the 3 cases, you should be fine. So since it's case 1, I is minus infinity to infinity, R is infinity. Okay, question. Now, there is one more step we need to take before you can start solving differential equation. That's part D, right? Well, the way we end this, who has a marker? N is 2 to infinity, n plus 1, no, it's n minus 1. an xn minus 2. So you are asked to express it in such a way that you have xn. Okay, so that's question 1. Now, the way you do it is, where is our x here? In this question, this is our x. And what's in our x? N minus 2, right? But we want to change this n minus 2 to be x to the n. That's what we want to do, right? That's what the question is asking. So we can say, let k be equals to x to the k. And we can say k is n later on. It's possible to do that. So it's called series shifting. So if k is n minus 2, let's replace everything here. So this series, you understand why I'm using k is n minus 2, right? Because the question wanted us to make this x to the n, meaning x to be alone, not minus 2. So we can say let k be n minus 2 to help us achieve that. So if k is n minus 2, this series becomes summation infinity. Instead of n here, it becomes, our n is k plus 2. So it becomes k plus 2 equals to 2. Right? N is k plus 2, it becomes k plus 2. Then n minus 1 becomes k plus 2 minus 1, like that. So an becomes ak plus 2, because then this x becomes sk, like that. So this becomes infinity, k is 0, because 2 minus 2 is 0, right? So k plus 2, this becomes k plus 1, ak plus 2, x to the k. So you can see that we've shifted this series from starting from 2 to starting from 0. So you can then rewrite in terms of n if you want. You can write in terms of n, or leave it like that. If you write in terms of n, all you just need to do is replace k with n, or n naught if you want. So that becomes summation n naught is 0, infinity, n naught plus 2. I'm just replacing k with n naught, or you could leave it as k. It's possible. N naught plus 1, a n naught plus 2, x n naught. So you can see that this one does not have that plus 2 again now. So that's our answer to the question. It's starting from 0. We've made this, instead of n minus 2 now, is now something, a factor that does not have minus 2. You need to learn how to do this because we use it a lot when we're solving differential equations. So you can try question 2 yourself. Try question 2. Let's deal with this guy. This x can come here and multiply. It's possible, right? So this becomes summation like this. N is going from 1 to infinity. N, a, n, x, n minus 1 multiplied by x to the 1. So that gives, you're going, n is going from 1 to infinity. N of a, n, x to the n, because that one is 0. So this is already having this factor, right? But there is a problem. This is starting from 1. This is starting from 0. Before you can add series, they have to start from the same point, right? We can swap later. For example, we can say let k be n to be like that. That works. The only problem is they are not starting from the same point. So we either have to shift this to start from 0, or we shift this to start from 1. That's the only way we can add them together. Right. Okay, so the easiest way is let's shift this to start from 0, then we can add them. Now, how do we shift this to start from 0? Let me show you how you do that. Does anyone know how to shift that to start from 0? So let's assume this guy here is summation. We want to shift this to 0. Is summation n to the 0. Right? It means n is 0, a to the 0 x raised to the power 0 plus n is 1 a to the 1 x raised to the power 1 plus when n is 2 a to the 2 x raised to the power 2 like this plus n is 3 a to the 3 x raised to the power 3 like this. Do you agree with me? That's what it means, right? Because it means n is 0, n is 1, n is 2, n is 3. That is what it means, right? So everything here, because this is n is 0, this is n is 1, this is n is 2, right? This is n is 3, and you keep going. So everything from here is the same thing as saying is summation n starting from 1 also to infinity n a raised to the power n x raised to the power n. Do you agree with me? Yes, because this is n starting from 1, 2, 3 to infinity. So now it's n to the 1, the same series.
Yeah.
So what that means is summation n 0 infinity n a n x to the n is 0 multiplied by 8 0 x to the power 0 plus summation n to the 1 infinity n a n x to the n. This expression is true. And everything here is 0. Everything here is 0 because 0 multiplied by 0. So that means this guy, if you shift it to 0, is the same as this guy. If you shift it to 1. Great. So we've shifted to 0 now. We can then add it. So that becomes, this guy becomes now, if we shift it to 0, it becomes summation n to the 0 infinity n a n x, right? X to the n. Right. Then you can add it to, all you need to do is, in series, the numbers doesn't matter. This could also be, you can say n is k, it's okay, because the number doesn't matter. What matters is where they are starting from. So you can add it to summation. You could say here n is k. It doesn't matter. So we can add them here. So n is 0 infinity a n x n. So let's add both together. They both start from 0 now. And we can add them together. If we add them together, this becomes, I brought 4 dead markers to this class. It becomes summation n from 0 to infinity. These two guys appear here, right? So this is a n plus 1. Someone should tell me, wake me up, please. This is a n plus 1, right? I think I missed something here. Because n is n plus 1. Is that correct? Did I miss something? No, I did not. Sorry. I thought I did. I just want to be sure I didn't make a mistake. Okay. A n x n n plus 1. Okay, that's what you got. Question. All I did was, if you factorize this out is 1, factorize this n. Okay. You can try question 3, which is much more easier if you're done. I'll give you a lot of time to do that, and I'll go around and see to make sure you got that.